So what do you guys have for ionic bond definition?
Bond between two ions?
I like that. Bond between two ions. Anybody else got anything?
I can't remember what I wrote, but it had to do with the electrons, gaining and losing electrons. They transfer the electrons.
How about, is that bottom part always true between a metal and a non-metal? It's not. It's just almost always true. If you see a metal in a chemical formula, what kind of bond do you have? You've got an ionic. Automatically, you've got an ionic bond. But just because there isn't a metal there, does that mean you don't have an ionic bond? Can somebody give me an example of a non-metal ionic bond?
Sodium and chloride.
No, sodium's a metal. I can't see that thing. Let me put that down. Is there a metal there? What kind of bond is this? Why is it ionic? Because it's got a polyatomic ion. So if there's an ion there, then you must have an ionic bond. So those times when ammonia is present, the molecule could be metal-free and still be ionic. What else with that? I feel like I was going to say one more thing. Does anybody have anything else to add to that? No? All right. Okay, so how about this one here? Let's make this tiny. Okay, so we're going to fill these boxes in, and let's go ahead and fill the sodium row in. Let's go with that. So if I'm going to put sodium, and when sodium goes in and makes a compound, what ion does it form? What charge does it take? +1, right? How do you know that it's going to be a +1? Because it's in group 1, right? Column 1. So then if the sodium every single time is going to be a +1, then I need to manage out my charges. So if I've got a +1 and a -2, it's going to be Na2S. You okay with that? All right. And then, so does the NaCl make sense? Sure. It's a +1 for the sodium and a -1 for the chlorine. And then when I move over to the sodium nitrate, it's sodium nitrate because I've got sodium +1 and nitrate -1. So what's the sulfate's charge? SO4 -2. I would probably go ahead and change these polyatomic ions to what their formula is with their appropriate charge, and that'll probably make the putting together of the ions quicker. With all of these, it's least common multiple between the charges, right? So with NaCl, the least common multiple was 1, so you just need one of each. And least common multiple for the sodium sulfide is 2, so I need 2 sodiums and 1 sulfide. And with the nitrates, it's 1 to 1, and with the sulfate, it's 1 to 2, so 2. So then I'm going to need an Na2 and then an SO4. And for the carbonate, it's the same situation because carbonate is a 2, CO3, so CO3 -2. And the phosphate, Na3PO4, because this is PO4 -3. So can you tell me what is going to be the same about the next row? How are rows 1 and 2 similar to each other?
Silver has a +1 charge and so does.
So what is that going to mean?
To look similar as far as setting it up.
The setup is the same, right?
Yeah.
the ratio of the cation to the anion is identical. The only thing that's different between row 1 and 2 is I change Na to Ag, but all the numbers stay the same, right? Silver's got a +1 charge, sodium's got a +1 charge, so you're going to end up with the same ratio. So then this is going to be AgCl, and then Ag2S, and then AgNO3, I can't really see that, and then Ag2SO4, and then Ag2CO3, and then Ag3PO4. Which other, what else is going to look the same? Is there going to be another row that looks similar to this? I'm sorry, say that again?
Calcium.
The calcium row? No. The potassium row for sure. This row is going to be exactly the same. That row, and this row, and this row, and this row too. Right? That's also a +1. So those ones that I've got circled in red, their ratios are going to be identical. There isn't going to be anything different about them except I change out the formula name. I'm going to run through the ammonia one just because it's a little, because I got the polyatomic ion there, and I don't know, I think we should. So let's go ahead and do that one. So I'm going to write NH4Cl, and then NH4 parentheses 2S, and then I've got NH4NO3. So there's an example of a polyatomic ion, no metal, still ionic bond, right? No metals in that ammonia nitrate, but I'm still ionic. And so then I've got NH4 parentheses SO4, and then an NH4 parentheses 2CO3, and then an NH4 parentheses 3PO4. That doesn't look like a PO4. Oops. Okay. So what's the name of the next ion in the next row? It's mercury. The name of just the ion is mercury 2. Every single time I'm going to name an Hg plus 2, it's mercury 2 because it could be mercury 1. So I'm going to have to designate as to what it is. So this is going to be mercury 2 chloride. And so my mercury 2 chloride is going to be HgCl2, and then HgS, and then HgNO3 2. And then I got an HgSO4, and an HgCO3, and an Hg3PO4 2. Are we okay with all those guys? The least common multiple on the last one is 6, right? Plus 2, plus 2, plus 2, minus 3, minus 3. Then everybody cancels out and I'm at 0. What's the same about the next row?
It's +2.
It's plus 2, right? Well, if it's plus 2, then it's going to be the same, right? So this row here, and this row here,
Magnesium.
and this row here, and the copper row, right? And the barium row. All those ones that have got circled in that light blue color, all of those things are going to be exactly the same as far as their ratios go. They will be identical to each other. So whatever you've got in the barium row, it's going to look exactly the same as we have in that mercury row. I just switched Ba for Hg, but the ratios are going to be the same. They have to be. So the only two that aren't the same, then we've got that aluminum row and that manganese row. So I'm going to run through those guys. Let's go with, how about orange? All right, so I've got a AlCl3. I've got an Al2S3. I have an AlNO3 3. I have an Al2SO4 3. I have an Al2CO3 3, and I have an AlPO4. And then the manganese one is just kind of funny. it's MnCl7, then Mn2, S7, and then MnNO3, 7, and then Mn2SO4, 7, and then Mn2CO3, 7, and then Mn3PO4, 7. What's the least common multiple between 7 and 3? 21, right? So I need plus 7, plus 7, plus 7, giving me plus 21, and then minus 3 7 times, giving me minus 21, so they cancel out with each other. So that one's kind of funny. And if you look at manganese down for its oxidation numbers on the periodic table, it's got a whole bunch. All right, I'm gonna skip over the rest since they're basically copies of the other ones. All right, so in each of the columns, the gray ones, so okay, so column number 1. What's column number 1?
Mercury 2, chloride.
Is everybody okay with that? What does the Roman numeral 2 stand for? The mercury's charge. And I need that because mercury's charge isn't set. So I'm going to have to tell the person when I tell them the name. And the second one, what's the formula?
Mg2S or MgS.
MgS. Okay, so I've got
Magnesium sulfide.
okay, so why do these both end in "ide"? Say again? No.
There's only one of them.
There's only one anion, right? It's not a polyatomic ion. So all I've got is just some non-metal that's got a charge on it. And what charges do non-metals gain? Positive or minus? Minus, right? Because the non-metals are the ones that are gaining electrons. So in this case, the magnesium probably gave its electrons to the sulfide, and so the sulfides, the sulfur turns into sulfide. So in sulfur, what do you know about its protons and its electrons? In sulfur, they're equal. And in sulfide, what do you know about the protons and electrons? It's got more electrons than protons, which makes its charge negative. So in this case, it's sulfur, so its charge is going to be -2 because it's in oxygen's column, so it'll gain 2 electrons. So since the sulfur gained electrons, we swapped the name to "ide." In the one prior to that, it was chlorine, gained an electron, and since it gained an electron, we just changed the suffix to "ide." So those guys are monatomic ions, anions, and so they gained a charge, gained an electron, forcing a negative charge, so we call "ide." How come I don't need to say magnesium 2 sulfide?
Because its ionic number is the same, the charge is the same.
It can never have a charge other than 2, so I don't need to write 2. The only time we use the Roman numeral is if the charge could possibly be something other. And since any time you ever see magnesium in a chemical formula, its charge is +2. There's no reason to say it. What's the formula for number 3? AgNO3. So I've got silver nitrate. So why silver? Why not silver 1? It doesn't change, right? So of the transition metals, remember it's silver, cadmium, and zinc were the transition metals with fixed oxidation states. So even though it's a transition metal, I don't need to give the state because it's fixed. And nitrate, with the polyatomic ions, I'm always just gonna go ahead and say their name. Doesn't matter how many of them there are, just say it. Formula for number 4?
Copper 2 sulfate.
Okay, so I do have to say 2 because it's copper, and copper could be 1 or 2. And then I've got sulfate there. So if I've got a +2 and the sulfate's a -2, then they just cancel each other out. So it's just CuSO4. And you guys have used that in class. It's that really pretty light blue, aqua blue kind of color. Okay, and the formula for number 5? What's the formula?
NH42CO3.
Okay, so I've got 2 polyatomic ions, so how do I name that?
Ammonium carbonate.
Not very good with my U's and M's today. U-M. So polyatomic ions, just say their name. Doesn't matter that there are 2 ammoniums. You're supposed to know that the ammonium's charge is a +1, carbonate's charge is a -2, and then you put them together appropriately. Remember what this is for. I have a formula, I write a name, but what if I have the name? Then I have to go backwards to the formula. So I need to be able to distinguish what the formula is just given a straight name. And you can do that with ammonium carbonate because their charges are fixed. So anytime you see a name without a Roman numeral, what's that tell you about the charges?
It's fixed.
All the charges of those ions are fixed charges. So I don't need to be designated as to which charge we're looking at. So formula for number 6?
K3PO4.
K3PO4. So I've got potassium and I've got phosphate, and both of their charges are what? Fixed, right? The potassium is a +1 because it's a group 1 metal, and the phosphate is a polyatomic ion, so its charge is fixed. So then it's just going to be
Potassium phosphate.
That's it, potassium phosphate. Are we good with that? Okay.